Okay, folks. So here's a quick tutorial on how to solve a system of equations in 3 variables. Now this one is a pretty special pretty special system because, as you can see, z is already solved for you right here. And so it's pretty obvious that we can do the substitution method for this one. But I'm going to do it with matrices as well at the end of this. So if you want to hold off and do this with matrices. So what we have to do when we have a system of equations, of 3 equations, is we have to create a system of 2 equations. And we're going to do that by taking this z and replacing it into this equation, and taking this z and replacing it into this equation. So I do that by rewriting this equation out and replacing the z. So the z is negative 3x minus 1. And then I do that in the second equation as well. I replace the z with negative 3x minus 1. Okay? So when I do that and I have that information, I need to simplify these equations. So I'm going to show you my simplifying. If I simplify my equation, I'm just going to rewrite this just so you can see it. And then I go through and simplify. So what you should do right now is you should pause this, simplify both of these, and see if you come up with what I have. Okay? But I'll still talk it out. But you should still pause. All right. So when I go through and I simplify this first equation, I have to distribute my negative 3 among the parentheses. So I have plus 9x plus 3 equals negative 9. If I want to simplify more, I combine like terms, so I get 8x minus y equals negative 12. And that's my combining of like terms. So that's my first equation. I'm going to call this number 1 again. Right? Now I'm going to simplify the other equation. If I simplify the other equation, I just rewrote this right down here, same exact thing. I distributed that negative through. I combine like terms, and I'm putting the x and the y on one side of the equation. So I'm subtracting 5y, and I'm subtracting 3x. So in all, I get x minus 3x is negative 2x, and minus 5y equals 24. So now I have 2 equations here. Since I have 2 equations, I can go through and solve this system as I would solve any system that I've been given. So one case, you can solve this system, and I'm going to cover this up. You can solve this system by substitution, right? We can solve for y and plug it back in for y here in this second equation. So again, press pause, see if you can do this through substitution, and then come back to it. If I do this by substitution, I take this y and I put it over to the other side of the equation, and I take this negative 12 and put it over to this side of the equation. So I get y equals 8x plus 12. If I take that y and replace it into the second equation, it's going to look like this. Negative 2x minus 5 times y, which is 8x plus 12, equals 24. When I go through and do the math, I simply distribute, simplify, and solve. And I get x equals negative 2. So hopefully you got x equals negative 2 also. Now, how am I going to go and find out what the what the y and the z are? Well, I'm going to go back to my original equation. And right here, I have z equals negative 3x minus 1. So if I know what x is, I can find out what z is. And I'm going to do that. So if x is negative 2 and z equals negative 3x minus 1, I simply plug negative 2 into my x, and I get z equals 5. So far, I have x equals negative 2 and z equals positive 5. Now, again, I'm going to go back to my original, and I'm going to say, well, if x equals negative 2 and z equals 5, I can plug it back into this equation to find y. I could have plugged it back into this equation to find y too, but I just chose to do this one. So, if x equals negative 2 and z equals 5, let me push this up a little bit. x equals 5y minus z plus 23. That's my original equation. I plug in negative 2. I plug in positive 5. I get 5y plus 18 equals negative 2. I divide both sides by 5 because I subtracted 18 on both sides. Let's make sure we know where we got that negative 20. And now I have y equals negative 4. And I'm not really done. I know this is a lot of work, but I'm going to go back and check. Okay? So far, I used this equation and this equation to find out x, y, and z. So I'm going to go back to this equation to check. So if my final answer is x equals negative 2, y equals negative 4, z equals 5, I'm going to go in and put those into my equation. So negative 2 minus negative 4 minus 3 times 5 equals negative 9. That's 2 plus 4 minus 15 equals negative 9, and that is a true statement. So you know that you're right. So I'm going to keep going on. If you're fine with the substitution method, you can pretty much stop this video. But I also want to show you how to do this using the elimination method and using matrices. So we're not going to go back to the very original equations. We're still going to use these two equations that we already manipulated. Okay? So here we have these two equations we've already manipulated. How do we solve that using elimination? Okay, well, there are two ways to do that. If I want to do this by elimination, I could multiply the bottom by positive 4. Because if I multiply the bottom by positive 4, I'm going to be able to get rid of my x. Okay? So this is that. So again, pause it, do the work, and see if you come up with the same answers. So I'm going to rewrite this first equation, and then I'm going to rewrite the second equation as I distribute through that 4. So I get negative 8x minus 20y equals positive 96. Because this is an 8x and a negative 8x, I'm going to add these guys. So I'm going to get negative y minus 20y equals negative 21y equals 84. And so I divide both sides by negative 21, and I get y equals 4. Y equals 4. So if I go back to my original equation and look for the y, I really can't use the y in these two equations because I still have missing variables. So I'm going to go and just go back to this equation to find the y. So I go back to this equation to find the y. I'm sorry, the x. I plug negative 4 in, so I get 8x plus 4 equals negative 12. 8x equals negative 16 because I subtracted 4 on both sides. So x equals negative 2. And now I can go back to one of my original problems. And I can write negative x minus y minus 3z equals negative 9, and that's just the original problem. If x equals negative 2 and y equals negative 4, I simply plug those guys in. So negative 2 equals 2, minus negative 4 equals 4. So 2 plus 4 is 6, minus 3z, and that equals negative 9. I subtract 6 on both sides. I get negative 3z equals negative 15, and z equals 5. Okay? And we got the same answers as we got last time. We could go back and check, but we already did, so we don't have to do that. Now, there's another way to do elimination. I could have also multiplied the top by negative 5. Because if I multiply the top by negative 5, I get negative 40x plus 5y. And if I have a positive 5y here and a negative 5y here, I can add these two guys together. So here's the process to eliminate by eliminating y. So I have negative 40x plus 5y equals 60. That's this guy. And then I simply rewrite this one, and I add, and I do the math, and I get x equals negative 2. Just like the very first one, I go back to the original. If x equals negative 2, and the original said z equals negative 3x plus minus 1, then I put the math in and I get z. Then again, I go back to the other original, I plug my x and my z in, and I'm going to get 4 again, negative 4 again. Now, last, and I know this is a long video, now we're going to do matrices. The difficulty with doing this with matrices is that they're not in any kind of order that I can make a coefficient matrix. A variable matrix, and an answer matrix, or a constant matrix. So I'm going to have to manipulate these equations to make it look like x, y, z equals something. Okay? So if I manipulate this one, I don't have to. X, y, z equals negative 9. But here, I have to put this 3x over to the other side. If I put this 3x over to the other side, I'm going to have 3x plus z equals negative 1. But that means I don't have a y there. So I'm going to have to put a placeholder, okay? And a placeholder is going to be a 0y, because you know that if you add 0 to anything, it doesn't change. So for my second equation, I rewrite it as 3x plus 0y plus z equals negative 1. And again, I need that 0y because I need to have a placeholder in there. So pause this, try to put these guys all on one side, the x, the 5y, and the z, put those all on this side, and see if you can come up with what you have to do there. So I'm going to have my x, I'm going to subtract my 5y, I'm going to add my z, and that equals 23. So now I have this beautiful system that I can make into my coefficient matrix, my variable matrix, and my answer matrix, or my constant. So again, pause it, write it, solve it, and see if you come up with those same answers, because we should. So here are our matrices. Here's our coefficient matrix. You see why we needed to have that placeholder? Because we have to have a 0 in our matrix in order to get our answer. X, Y, Z, negative 9, negative 123. And then I put that in my calculator, and you're going to find that you still get the same answer. So this is a tutorial on how to solve a system of equations in 3 variables by using substitution. How do you think you're going to do it by using elimination from the very beginning? That's next.